Hey, how are you doing, guys? I'm Dohan. Here's this in 9 part 1. In this video, we are going to discuss regression based on Rosmann's Kaggle competition. Then we are going through the permutation importance technique. So let's get started with our lesson. Today we will work with Rosmann's Kaggle competition, which was a business sales prediction competition for $35,000 for the winners. The premise is that we are given the sales data and information of their stores for the past few years. We need to make a model that can predict the number of sales that will be made in the future. So we can do this through a tabular regression model. And we will work with a clean engineered dataset straight from Kaggle. First, let's see how we can download the dataset. So let's go with this link. Jeremy discussed a technique to download data from Kaggle without needing the Kaggle API. So we are going to use Trend Clean and Test Clean. These are already made datasets for us. And what you need to do is to copy the link address of them from here and paste it here. Let's make it for test again. And then run wget. Now we have our data, and the data now is stored into pickle files. Now let's install fastai library. And treat our data, we are going to use pandas to treat pickle. Here we show the head of the data, but we transpose it. So as you can see, we have 93 columns. Then we define our categorical and continuous variables, and the reason of why we have the feature engineering because it allows us to create some sort of categorical variables that we can use for our embeddings. So here we created school holiday FW and competition months open and more. When doing regression with these large numbers, we often use the log of these values of our y's, so let's transform them. Here we call numpy.log and pass it our y's, which is our dependent variable. Then we declare our preprocessors like fill missing, normalize, and categorify. And for the splits, because we're dealing with time series, so our training data has a particular time range. So if we take a look here, our test data frame has a timestamp from the beginning of August of 2015 to the mid of September. And for our training data frame, it starts for the beginning of 2013 up to the day before the test data frame. So what we are going to do is to mimic this test set for our validation set. And our validation data is going to be the last month and a half of the training data. So that's what this particular index here is going to find. So the time in which we are about month and a half out is row 41,395. Now we can go ahead and make our splits to mimic this. And now let's make our tabular pandas. Since we have a large data frame, we can use some new options like in place and reduce memory. To use in place, we need to set a chained assignment to none in pandas. Then we go ahead and define our tabular pandas, so we pass it our training data frame, the preprocessors that we defined, our categorical and continuous variables, our dependent variable, and one thing that we did differently here is passing it the regression block to our y block, just to say that we are doing regression. Then we pass it our splits, and we set our in place and reduce memory to be true. Then we can build our data loaders by calling two data loaders, and we set the batch size to be 512. And here's a batch of our data. Now the key thing with regression, especially in this kind of problems, is we should declare the Y range. So here we grab the maximum value from our training data and we multiply it by 1.2, and remember we have applied the log to our Y's. So our maximum log value is around 12.76, and we can define our range from this by calling torch.tensor, and we define the range from 0 to the maximum log Y. Then we define our learner by passing it our data loaders, two fully connected linear layers, 1500 neurons. PS here is dropout, so we pass it two parameters for these two layers specifically. The dropout for our embeddings, our Y range that we defined, our metric, which is exponential root mean squared percent error, and for the loss function, we are going to use mean squared error loss flat. And if we take a look at the model, we have all of these embedding layers. Then we have two linear layers. The first one is 512 by 500, and the last one is 512 by 1. Then let's find a learning rate. Then we fit for 5 epochs, and here's the results. Now let's take a look at what inference on the test set would be without the original data. First, we are going to export the model using learn.export. Delete our learner, that way there is no references the data tied in with our learner. Then we call load learner. And as usual, we go ahead and made a test data loader from the test data frame. Then we pass it with predictions. And if we take a look, we have this 2x1 array with our predictions here. And if you notice, we have none. This refers to any labels if we had any. This is nice because if we accidentally run a learn.validate on non-label test set, as we did here, as you can see here, we have this none because there is no labels. Now let's go back to our predictions. Remember, we convert them to the log. Now we need to undo that. For this, we call numpy exponential function. So here we get our original values. Then we can turn them into a regular numpy array. Now that we have our detransformed values, we can go ahead and submit this to Kaggle. To do this, we can use these prediction values into our sales. Then we ensuring that they are integer types. And then we can make our submission, and you need to make sure that you set the index to be false. Let's go with permutation importance. So permutation importance is a technique in which we shuffle each column in a data frame and analyze how changing a particular column affected our Y values. The more it was affected, the more it's important. So let's take a look at this algorithm. The things that we need to keep track of are our data frame, the names of X values, what is the ma, our Y's, and when you are doing the permutation importance, there's two ways to think about it. You can do permutation importance in your validation set or on the test set. So these two different sets tells you very different ideas. The one in the validation set tells you when your model was training, what it was looking at, whereas using the test data frame tells you how does your model perform when it needs to be generalizing, when it sees unseen data, what's behavior. So our algorithm here is going to check to see if we pass in a data frame or not. If we don't, then it assumes that we are going to use the validation data loader. Otherwise, we'll build the data loaders. And then if we are following this along, we see that the self.results here is calc feature importance. So let's take a look at this function. This function first calculates the base error. Then it loops for every column in all of our x's. We run the major column function on them. So the major column function is where we are doing the permutation. Now tabular pandas is cool because it allows you to keep everything as a data frame. You can modify the tabular pandas object in a data loader and it will update all of the patches automatically. First, it takes a column and we want it to be an array because if it has some nav values, we will shuffle them too. Then we keep track of the original values. Go ahead and do random permutation. Reassign our values directory in a data loader based on these permutations. Then we run learn.validate on it. And then we replace those values back with the original. And the rest are just the helper functions that can help us for the visualization. So if we run permutation importance on the training data frame, this is what the permutation importance looks like in the first 1000. As you can see, max humidity, events, mean temperature C, max wind speed, and mean humidity have an impact. So we can might train on only these 5 values and see if removing the lower values improves the accuracy or not. And we adjust the algorithm to return a dictionary of all of the values in case you need to take a look at it again. So here is the dictionary. And that's it for today's video. Hope you enjoyed.